This was something actually that you're going to do that was on your test, and you almost all of you missed it. So let's just rehash it, and then we'll get into the topic for today. So go ahead and put this into your notes. Sketch a coordinate plane. Doesn't have to be perfect, just to get the idea. And the question that was on your test that we had a hard time with was find the reference angle. In fact, this was even more frustrating. On your test, in the directions, I even told you what that was. What is a reference angle? It is the angle formed. My pen is not helping me out. It is the angle formed by a terminal ray and the x-axis. So let's say I have the point, and in this case it's going to be a vector. But for now we'll just say the point. Let's say I have the point -4, -6. So, well, where is that point? Well, that point is like down here somewhere, right? And you would draw this, which most of you did on your test. You're like, all right, there's my point. And then most of you went ahead and completed the triangle. That's good. And then this is 4, and then this is 6. You can throw the negatives in there if you want. And then we messed it up. Okay? Many of you found this angle in the end, but that is not a reference angle. The reference angle is this angle in here. So if I want that angle, I have opposite and adjacent. So the tangent of my angle is 6/4. And now how do I get my angle? If ever in trigonometry I want my angle, what do? I use an inverse. Josh. 6/4. So I inverse tan 6/4, and what do I get?
.98.
Make sure you're in degree mode.
Oh. .56.3.
Okay, that's the reference angle. Now, what many of you did on your test is you went ahead and found that, and then you added 180 or something like that to find this whole thing, and then that's not. Some of you didn't even get to here. But do you recall this? Getting that reference angle, or should we do another before we get into the thing for today? Okay, I guess we are good. So what we're now going to do is we're going to find the direction of a vector. All right, well, let's say I have point C. Let's say that point is 1, 3. And let's say I have point D. My pen is really not cooperating. Let's say I have point D is 4, 9. And I want to find, well, let's find a bunch of things. We're going to find the vector form, which is what you did for homework yesterday, finding the vector form, or the component form, it's also called. Let's find the magnitude. And let's find the direction. All right, well, to get vector form, how do we do that? I want vector CD. So how do I get that?
4 minus 1.
Yeah. I'm going to do 4 minus 1. Yep. And I'm going to get 3, 6. That's the vector component form of CD. Vector CD. And what we need to remember is that we actually do that backwards, right? We go, if we want the vector drawn from C to D, to actually get that, I do D minus C. All right, so that's our vector form. Now, how do we get our magnitude? Well, the magnitude of CD is basically Pythag. So I'm going to do square root of what?
plus 36.
Yeah. So 3 squared plus 6 squared, which is, as Jarrett said, 9 plus 36, which is square root of 45. And then we do need to simplify that. It will become 3 root 5. Anyone need to know how we get that? Okay. So that is our magnitude. So we have our magnitude, our vector forms. Let's just itemize these. And now we are going to get our direction. Well, our direction is basically the angle. So like we started class with, if I draw a little sketch here, well, where is this vector? So I got it in component form, this 3, 6. So 3, 6 is somewhere up here. So this is my vector, and I just vector transport that to the origin. And now I want this angle. So that basically is going to be a tangent problem. So tangent of my angle is opposite over adjacent. And then I inverse tan that. Whenever I want an angle, I do inverses. So I'm inversing tan of 2. And what do I get for my angle? Okay, so there's my direction. So something that we have already done. So let's do
435.
435. Okay. Close enough. I mean, if you're traveling a far distance, that might make a difference, but for a short distance, not that big a thing. Okay. Let's try 2 more. Maybe I give you the vectors. So let's say vector u is 3, 2. And let's say vector v is -2, -5. Let's find the directions of these. And when we find directions, we want to note our quadrant. Okay, that's something that messed some of you up on your tests, was not remembering which quadrant you're in, so not knowing the signs of your answers, which let's just briefly review that. So let's talk about the signs of sine, cosine, and tangent. So in quadrant 1, sine is positive, cosine is, and tangent is, okay? We need to know this, and we need to remember sine is y's, cosine is x's. That's going to become prevalent here shortly, and tangent is sine over cosine, y over x. All right. How about quadrant 2? Sine is positive, cosine is negative, and tangent is negative. And sine down here, negative, cosine, tangent. So sine, cosine, tangent. And over here, quadrant 4, sine is, cosine is, and tangent is. Okay, so you need to keep those in mind. All right, so this is in quadrant 1, so everything's positive, and this one's in quadrant 3. Okay? All right, so this one, I want the direction. Now, I really don't need to sketch it out. Tangent of theta is going to be opposite over adjacent. This is going to be the opposite, and this is going to be the adjacent, so it's going to be tangent of 2 over 3. But if you need to sketch it, that's okay. Just do a little rough thing. Okay, 3, 2. All right, here's my triangle, and then this is 2, and this is 3. I did, wait, that's 3, and that's 2. Okay, and then whenever we want an angle, we do.
Mr. Kelly,
Yes.
can you send Josh Davis to the desk, please?
Sure, why not?
Thank you.
Bye, Joshy.
Have you ever told someone no when they ask something like that?
I should try that sometime.
Josh?
It'd be
Are
great.
you leaving or should getting medication?
Oh, Josh is dead. All right. He's beating me up. Abuse. All right. What do we get here?
34.
34. So, good. How about vector? So that's the direction of vector u. What about vector v? Tangent of theta is negative 5 over negative 2.
60.
And we do get, what, 68.2 degrees about? Okay, so, but no, this is why we noted our quadrant. We are in quadrant 3, aren't we? So that means what we found, remember reference angles, we found our reference angle. This is the case where we need to add a little bit extra to this. So how much do I need to add to that 68? 180. So what is my actual direction? Okay? Now, I'm fairly confident that when your book shows you how to do directions with these, it does not use tangent, it uses sine or cosine. And all they're doing is they're trying to eliminate some of this adding of 180, but I think it's just as easy to remember your quadrants and use tangent to find your angles. Alright, now, let's find the vector from a magnitude and direction. Okay, so let's start with an example. Okay, Josh pushes
Me.
our cow from yesterday with a force of, I don't know, let's make him 500 newtons at 60 degrees. What are the components of the vector? Basically the component form. So we'll draw a rough sketch, very rough sketch apparently. And here's our 500 Newton force. So now we know the hypotenuse of our triangle. And we're at 60 degrees. So here's our 60 degrees. Do you see how I'm setting this up? And now it looks like a triangle. And what I need to find is this x right here and this y right here, right? Okay, so there is a fast way set up to do this if you want. But for now, let's just do it like we would have done in the last chapter. How would I find y, Jarrett?
Y?
Mm-hmm.
Sine 60.
So, yep. So the y component is 500 sine 60, which is what? Okay. And how about, Cambo, if I wanted the x component, what would I get?
Would you do cosine? I mean, no, you would do
Yes, cosine.
no cosine.
Cosine 60.
X over 500.
Yep. So x is 500 cosine 60, which gives us what for x? What's the x component? 250. Okay, so what is our answer? What is the component form? 250, comma, 433. Now, we can do every problem that asks us something like that. We can do it the way that we just did. And really, it doesn't change anything. But you may want to know this. The magnitude, it always comes down to this. Our component point is going to be the magnitude of our vector times the cosine of the angle, comma, the magnitude of the vector times the sine of the angle. Every single time. So, if I want the components of a 600 Newton force at, let's say, 220 degrees. I don't really need to draw my triangle. If you want to do it that way, that's fine. But every single problem will come down to this. So I have my magnitude is given to me as 600. Then it's cosine of 220, comma, 600 sine of 220. This is where understanding that cosine has to do with x's and sine has to do with y's is really helpful, because then you don't really need to draw the triangle out. You can just plug into this formula. So, but if you want to draw that triangle again, go ahead and do it. Better safe than sorry. So what do we get for our first component?
Negative 459.6.
And our second component?
Negative 385.7.
And there we go. There's our components of our vector. Okay. Now let's go to our calc problem from yesterday. So, Jarrett pulls on our cow. At 400 newtons, 60 degrees. Josh is going to wrangle at, let's see, 450 newtons at 100, we'll say 100 degrees. And we ask, well, where does the cow go? Alright, so here's our cow. And we have our Jarrett, 60 degrees. So here's Jarrett. And at 400 newtons. And here's our Josh. Over here. Here's our Josh. 450 newtons. And now his angle is this, 100. Okay? So ultimately what we want to do is we want to get all the components and add them all up. Okay? So we want to find, what we're finding is, essentially we're finding what's called the net force. And the net force is the sum of all the forces acting on it. So I'm going to add them up. This is a sum. So, let's find the force of Jarrett. We'll call him force JA. Alright, well that's going to be, let's get the components. So we're going to have 400 cosine of 60, comma, 400 sine of 60. And the force of Josh, so force JO, is going to be 450 cosine of 100 and 450 sine of 100. Do you see what I'm doing there? Or do we not get it? Speak now if you don't get what we're doing. Now these are our two forces. Alright? To the nearest whole number, what is Jarrett's vector? The Jarrett vector?
246.
246. And what is the Josh vector to the nearest whole number?
Negative 78. And 440.
Okay, so remember yesterday, what did we do with vectors? We could add and subtract them. In this case, what do I want to do? Well, my net force is going to be the force of Jarrett plus the force of Josh, and I'm going to add those two together, so I just add those vector. And that gives me my resultant. So I get 200 minus 78. So what's the first x component? Say louder.
122.
122. And the y component?
789.
Okay. So our intuition should tell us that basically our cow should go this way. You know, somewhere in the middle, right? And if I were to vector transport Josh over to here and line it up tip to tail, that would seem to make good sense. So, but what we really want to know is, well, what's this direction and what's the magnitude? So I'm going to take this force, and we have it written down. We have our 122, and what was the other component? 7 what?
89.
789. Well, what we're really asking with this is, well, which direction? I want my direction, and I want my magnitude. And I can get that from our component form here. So let's get the magnitude. The magnitude is going to be the square root. So the magnitude of this net force is going to be the square root of 122 plus 789. Squared. Those two are squared. So what do we get for the magnitude?
Root 637,405.
Which is what? What is that root? Yeah. To the nearest whole number.
798. So 7.
Okay, so that's our force. All right, now what is our, so that's our magnitude. What's our direction? Well, our direction is going to be, now we need to know which quadrant are we in. What quadrant would these, well, they're both positive numbers, so which quadrant? 1, quadrant 1. So I'm going to get my angle next. So we inverse tan that, and what do we get for our angle? All right. So where does our cow go? Well, in reference to our coordinate, goes this way at a force of 798 newtons. Is that a lot? Is that a lot? Is that a lot of force? What would you consider to be a heavy object? New? And how many kilograms would you estimate you weigh? We don't know how many kilograms you weigh?
How many kilograms does a cow weigh? That's not, I was not equaling that out. I was just asking, that sounded really bad.
Well, force is your mass times your acceleration. So if we take Jared's mass, let's just give him a nice 200 kilograms. And the acceleration due to gravity is 9.8. We'll just round that to 10. So if we drop Jared from a height, he will hit the ground with 2,000 newtons of force and die. So, is that 798 a lot? I don't know. It's a little bit less than half than Jared falling. Yeah, that's a significant amount.
Cow.
Yeah, more than a cow. Well, we didn't drop the cow. Now, if we took the cow's weight and then did the same thing, we might find something else. So you don't need to know how to do that. That's not in your thing. We are measuring force in newtons. You could do it in pounds as well. We could also do these with velocities. So let's do a velocity problem, then we'll do some problems from your homework. All right, so let's say that we have Cambo in a river, in a canoe. So Cambo's in his canoe, and the river,
That's not like songs.
the river flows south at 5 meters per second. That's pretty fast.
Because I'm fast.
Okay, well, that's where the river's flowing. And we're going to say that Cambo rose at, I also make you go fast, 2 meters per second. West. Where does Cambo actually go?
From my look, probably down a waterfall.
Alright, so we have our river. So, oh, but it's traveling south. Gotta have an accurate diagram here. So here's our river.
Yep, you're going that way.
Okay, and that is 5 meters per second south. And Cambo's trying to go west. So here's Cambo in his canoe. He's trying to go west at 2 meters per second. Now, if we did our vector transport, we'd line these up tip to tail, and Cambo would be down there, and his resultant would be this, right? This would be our resultant, lining up tip to tail like we did yesterday. And we say that he should be going diagonal. So let's get some directions onto this that we can use. So we have our river is 5 meters per second at, now if we're going directly south, that's going to be 270 degrees. Does that make sense? And Cambo, he's rowing 2 meters per second at, well, if he's going directly west, does that make sense that that's 180 degrees? So our net, so now instead of talking about net force, we're talking about net velocity because we're asking how fast does he go. So our velocities are going to operate under the same principle as the forces did. So we have our velocity of the river is going to be 5 cosine of 270, 5 sine of 270, and the velocity of Cambo is 2 cosine 180 and 2 sine 180. And in the end, for both of these, we should see that the velocity here is going to be 0, -5, and the velocity for Cambo in the end is going to be -2, 0. And then what we do with these velocities is we add them. So our velocity final is going to be -2, -5. Do you see where I got that? As far as getting the zeros in the -5, -2, you can just plug that into your calculator. I was just able to remember that the cosine of 180 is -1, and the sine of 180 is 0. The sine of 270 is -1, and the cosine of 270 is 0. Well, but you can plug that into your calculator if you want. In the end, I just added those two vectors once I got them. But this doesn't answer the question. I want to know his magnitude, right? And his direction. So let's just, for this case, get the direction first. I'm going to do, now note which quadrant. Which quadrant would that final velocity be in? Quadrant 3. So I'm going to do the inverse 10 of -5 over -2. And the inverse tan of that gives me what? And now we're going to add 180, right? Because we need the extra piece there and get what? To what?
48.2.
Yeah, it's just an irony there. All right, so 248.2. So that's his direction. Now his magnitude is going to be the square root of 4 plus 25. So it's root 29. So where does Cambo go? Cambo goes at a velocity of square root 29 at root 29 at 248 degrees. That's its actual velocity. And then plummets over the waterfall. Alright, pretty much only the last thing we aren't going to spend much time on, that's going to be I hat and J hat. Sometimes you see these and they aren't terribly difficult. I hat is 1, 0 and J hat is 0, 1. So if I put as my vector 4 I hat plus 5 J hat, well, what does that mean? 4 or 5. I don't know why anyone would want to use that, but sometimes if I have just -3 I hat, that's going to be -3, 0. And if I had just 2 J hat, that's going to be 0, 2. Do you see what I'm doing there? J hat is basically Y, and I hat is basically X. So if you see those, that's what they are.